So, good evening, students. Good evening. Am I visible and audible? Can you just let me know in the chat box if I'm visible and audible and if my screen is visible to you or not? Give me a thumbs up or just let me know in the chat box by typing yes. Okay. Nigmavya, can you hear me? Yes or no? Okay, fine. So let me start with the class. So we are discussing the chemical bonding and molecular structure part, right? So we are at the end of the lesson now. So in the last class, we were discussing the molecular orbital theory. And I have discussed the postulates of molecular orbital theory and some cases we have seen, etc., etc. And at last, I was telling about the applications of molecular orbital theory. Okay. So from the molecular orbital theory, we can find out the bond order, bond length, stability, and magnetic nature. Okay. And I also have completed the bond order part somewhat partially in the last class. So there is one formula to find out the bond order. It is Nb minus Na divided by 2. So Nb denotes the number of electrons in bonding molecular orbital and Na is the number of electrons in anti-bonding molecular orbital divided by 2. And using this formula also we can find out the bond order, or we can go with the trick that is there on the screen. If the number of electrons in a particular molecule is 14, then the bond order is 3. Okay, if it is 13, just reduce 0.5. So just reduce 0.5, 0.5 as the number of electron increases and decreases from 14. Okay, so accordingly the bond order will be there for the molecule. Now coming to the second application, so it is the bond length. Bond length is inversely proportional to bond order. Okay, if the bond order is more, then the bond length is also more. Bond length is less. If the bond order is less, then the bond length is more. So they are inversely proportional. You see here, the first system is carbon-carbon single bonded system, in which there is only one bond between two carbons, so the bond order is 1. And in the second case, there are two bonds, so bond order is 2. And in third case, there are 3 bonds between carbon and carbon, so the bond order is 3. So as the bond order increases, bond length decreases. Bond length value decreases because they are inversely proportional. Okay, so this is just an example only. We can apply this for any of the molecules. Okay, now coming to the third application, it is stability. Stability is directly proportional to bond order. If the bond order is more, stability is also more. And if the number of electrons in bonding molecular orbital is more than the number of electrons in anti-bonding molecular orbital, then the molecule is more stable. If it is less or if it is equal, then the molecule is said to be unstable, or we can tell that the molecule does not exist. Molecule does not exist. Okay, so there is an example given here. So for hydrogen molecule and helium molecule, you can see the molecular orbital energy level diagram here. So sigma 1s denotes the bonding molecular orbital, right? Sigma 1s denotes the bonding molecular orbital, and the sigma star denotes the anti-bonding molecular orbital. Anti-bonding molecular orbital. And here in case of hydrogen, number of electrons in bonding molecular orbital is 2 and anti-bonding molecular orbital is 0. Okay, so Nb is greater than Na. So that's why hydrogen molecule is stable and it exists. But when you come to the second case, the number of electrons in bonding is 2 and anti-bonding is also 2 for helium. So here Nb is equal to Na. So if this is the case, if Na and Nb they are equal, then the molecule does not exist. Okay, bond order is coming up to be 0. So the helium molecule does not exist. Helium molecule does not exist as it is unstable. Got it? Now coming to the fourth application. It is magnetic nature. So there are two different types of magnetic nature. One is paramagnetic nature and the other one is diamagnetic. So the orbitals, molecular orbitals which have unpaired electrons, they are paramagnetic in nature. And if we bring that substance into the presence of magnetic field, the substance will get attracted to the magnetic field. Okay, so those substances are called as paramagnetic substances. And if all the electrons are paired up, then if you bring the substance towards the magnetic field, it will get repel each other. Okay, so they are diamagnetic. Substances are said to be diamagnetic. So just by seeing the molecular orbital energy level diagram, you can find out the given molecule is paramagnetic or diamagnetic. Okay, clear? So any doubt from the four applications of molecular orbital theory that I have discussed now for the person who is listening? Okay, fine. So let's go with the next topic, which is the last small topic of this lesson. It is hydrogen bonding. What is hydrogen bonding? It is the attractive force which binds hydrogen atom of one molecule and the electronegative atom of the other molecule. And those electronegative atoms can be fluorine, oxygen, or nitrogen. Okay. So let me take one example. So I have taken ammonia. Okay. And HF, hydrogen fluoride, and water. So all these three molecules have the capacity to form the hydrogen bond with the other molecule. So how they are going to form the hydrogen bond? So let me take this NH3. Okay. So there is one NH3 and this is the second NH3. So the hydrogen atom of one molecule forms the bond with the more electronegative atom of the other molecule, which is nitrogen. Okay. In case of HF, if I put another HF next to it, the hydrogen atom of one molecule will form the bond with the more electronegative atom fluorine of the other molecule. And in case of water, let me take two water molecule. Oxygen of one forms the hydrogen bond with the other. So all these dashed bonds which you can see, those are the hydrogen bonding. Okay. Now coming to the cause of formation of hydrogen bond. Why there is a formation of hydrogen bond in a system? So HF is there. Okay, HF is there. There are two electrons which is present between this HF. Okay, but fluorine is more electronegative than hydrogen. So what this fluorine will do, it will try to pull the hydrogen electron also towards itself. Since it is highly electronegative in nature, it will pull the electrons towards itself. Since it is gaining the electron from hydrogen, it takes the partially negative charge and hydrogen is taking partially positive charge. Okay, so now the molecule is polarized. Now the molecule is polarized. Molecule is denoted by plus and minus. Okay, so because of this, when we bring another HF to this first HF, because of this polarization, there is a formation of hydrogen bond between the negative end of the one molecule and the positive end of the other molecule. Okay, so you just see here, all these dashed lines, they denote the hydrogen bonding. So these are the hydrogen bonds. Okay, so this is the cause for the formation of hydrogen bond. Okay, and there are two types of hydrogen bonding. We have two types of hydrogen bonding. One is called as intermolecular hydrogen bonding and the other one is called as intramolecular hydrogen bonding. So what is intermolecule? It is the hydrogen bond that is getting formed between different molecules. Okay, or else I can say hydrogen bond existing between two molecules. They are called as intermolecular hydrogen bonding. Suppose if I take two HF like this, there is a formation of hydrogen bond and this hydrogen bond is called as intermolecular hydrogen bond. Some other examples are also there. Alcohol, water, all these are the examples. And coming to intramolecular, hydrogen bond is formed within the same molecule. So within the same molecule means it is within the same molecule. Okay, it is called to be intramolecular. The most common example is orthonitrophenol. So if I put a phenyl ring, and if I attach NO2 and OH, this is orthonitrophenol. And this is the complete structure of orthonitrophenol. So the oxygen of this nitro group is forming the bond with the hydrogen of the OH group. And that is called as the intramolecular, because the hydrogen bond is existing within the same molecule, right? So that is called as intramolecular hydrogen bond. Okay. So with this, the lesson gets over for us. Now let us solve some previous year's questions of JEE and NEET from this molecular orbital theory topic, and then we will start the new lesson. Okay. So chemical bonding here. Let's go with the question now. So here is the question for you. In which of the following process the bond order increases and paramagnetic character changes to diamagnetic one? So first let us calculate the bond order. Okay. So as I've already told you, there is a trick to find out the bond order. By using the number of electrons, we can find out the bond order. So now coming to option A, first we have oxygen molecule. The atomic number of one oxygen is 8. Okay, 2 oxygen is there, so it will be 16. So the number of electrons for oxygen is 16. If the number of electron is 16, then the bond order is 2. So bond order is 2. And from 2 to O2 2 minus. Already O2 has 16 electron. Now O2 2 minus means it is 16 plus 2, right? So it will be 18. If it is 18, let me write the trick first. 16, 17, 18 here, and here 15, 14, 13, 12, 11 and 10. And for 17 it will be 1.5, and for 18 it is 1. And for 15 it is 2.5, 14 means 3, and here it is 2.5, and for 12 it is 2, for 11 it is 1.5. Okay. Now O2 2 minus is having 18 electron. For 18 the bond order is 1. So here the bond order decreases from 2 to 1. So it cannot be the answer, because we have to find option in which the bond order increases. No. So this cannot be the answer. And coming to nitrogen N2, so the atomic number of one nitrogen is 7. 2 means it is 14. If it is 14, bond order is 3. N2 plus. So N2 means 14. N2 plus means nitrogen has lost one electron. So minus 1. So it will be 13. 13 means the bond order is 2.5. And in this case also the bond order decreases. So it is also not the correct answer. So coming to NO, for one nitrogen, atomic number is 7. And for oxygen, the atomic number is 8. 7 plus 8 is 15. 15 means the bond order is 2.5. Okay. And for NO plus, for NO, the number of electrons are coming out to be 15. And for NO plus, we have to reduce one electron, right? It has lost one electron. So it is coming out to be 14. 14 means the bond order is 3. So here the bond order increases. Bond order increases. Okay, so that is the correct answer. And you can check with option D also. Option D means for O2, already we have calculated, right? The bond order is 2 for O2, and O2 plus. Plus means 16 electron is there for O2. If it has lost one electron, then it will be 15. This is for O2 plus. 15 means the bond order is 2.5. And here it is increasing, but we have to check the paramagnetic character also. O2 is paramagnetic in nature. O2 plus is also paramagnetic in nature, because when you see the molecular orbital energy level diagram, you will have two unpaired electrons in O2. You have two unpaired electrons in O2. But O2 plus means you have to remove one electron. Means one unpaired electron remains still same. Okay, so both are paramagnetic in nature. But when you see for NO, NO plus is diamagnetic and NO is paramagnetic. Okay, so option C is the correct answer for this question. Okay, now let's move on to one more question. The correct order of energies of molecular orbitals of nitrogen is. So when I was discussing the molecular orbital energy level diagram with you in the last class, I have discussed for nitrogen, right? So electrons are filled in the increasing order of the molecular orbitals. So in which option D will be the correct answer? You can check this with the MO diagram of N2. Okay. So this is the energy level order, increasing energy level order. Now coming to the next question, identify a molecule which does not exist. So just now we have seen, no, helium is a molecule with the bond order 0 and it does not exist. O2, carbon, lithium, all those molecules will exist. So for all the other molecules, the bond order will not be equal to 0. So only for helium, the bond order is equal to 0. So the molecule is unstable and it does not exist. Okay. So with this, the chemical bonding lesson is getting over. Now let's start with a new lesson. So give me a moment. I will just switch on to that lesson and then I will come to you. Okay. If you're having any doubt from the chemical bonding, you can ask me. I can see some new IDs today. You guys are from which region, students? You guys are from which region? From which school? Which JNB? Tara, Veni, Mavya. You guys are from which school? Let me know in the chat box. Don't get scared. Just let me know. You guys are from which region? Because I haven't found such students before. So may I know the name of the JNB that you guys belong to? Okay, okay. So this is your first class for you guys? Till last class, whose teacher class you were attending? Okay, okay, no issues, no issues. We will discuss this later. Okay, fine. So coming to the new lesson, it is thermodynamics. Okay, thermodynamics. So in this lesson, we can divide this lesson into two. The first part is thermodynamics and the second part is thermochemistry. So in these two topics, I will give you the formulas that we are going to apply for the numericals for both JEE and NEET, and all the terms theory point of view also we will discuss everything. We will discuss here. Okay. So today I am going to take few topics for you. The first thing is the main topic is first law of thermodynamics. Okay, that is a very important topic that we are going to concentrate. And before moving on to the exact first law, we will see some basics of thermodynamics and internal energy, law of conservation of energy, types of work, and expression for work, enthalpy, internal energy relationship, and capacity. So we will try to cover as much as topics that we can for today, and if time permits we can do. If it doesn't permit, we will finish this in the next class. Okay, so coming to the first topic, which is basics in thermodynamics. So there are three terms you need to know. Okay, one is system, second is surrounding, third is boundary. Okay, so thermo means heat, dynamics means movement. So heat, movement. So we are going to study about this only in this lesson. Heat, movement. So system, surrounding, boundary. Who is the system? The one which is under study is called as system. Suppose if you are taking a universe and if we divide the universe into four, and if I want to study about the first part of that four division, that first part is called as system. It is the part of the universe which is under investigation, or I can say which is under study. Okay, you can see a picture here. That is a container and some gas molecules are present inside that container and one piston is connected with it. So now this is the part which is under study. Gas molecules is the one which is under study. So that is called as system. That is called as system, and all the observations are made on the system only. Now, who is this surrounding? The remaining part of the universe. The remaining part, you can see here. Okay, the remaining part of the universe is surrounding, and the boundary is the separation between system and surrounding. So this container is the boundary now. Okay, so system, surrounding, and boundary. So these three terms are very, very basic to the thermodynamics. And coming to the next slide, here we are going to talk about the types of process. So totally we have 5 processes. The first is isothermal. Iso means same. Iso means same. And thermal means it is temperature. So the temperature is going to be same. So temperature is constant. If the temperature is constant, then the change in the temperature is also 0. Change in the temperature will be equal to 0. Suppose if I am having two temperature T1 and T2, T1 and T2 they are equal. Means if I have to calculate the change delta T, it is T2 minus T1, final minus initial, right? Now both are same. Both are equal to 5 Kelvin. So I have to substitute 5 in both the part, right? 5 minus 5 will be equal to 0. So if something is constant, then change in that value will be equal to 0. Okay. And isochoric, choric means volume. So delta B is going to be 0. Volume is constant. So delta B is 0. And the third process is isobaric. Baric means pressure. So pressure is constant. So delta P is equal to 0. Delta P is equal to 0. And the fourth process is cyclic process. Cyclic means, you see here, I am starting from 1 and going to 2, and from 2 I am moving to 3, and from 3 I am coming to 4, and from 4 again I am coming to 1. So this is called a cyclic. I am starting from 1 and I am ending with 1. So the initial point and the final point, they are going to be same for a cyclic process, whatever or how many steps it can be there. Okay, whatever might be the steps, the initial final point is going to be the same for cyclic process. And coming to the last process, which is adiabatic process, adiabatic means there is no heat exchange between the system and surrounding. There is no heat transfer or heat exchange between the system and surrounding. So the walls, those kind of walls are made said to be adiabatic walls, and the process which is occurring in that system is adiabatic process. Okay, so these are the 5 types of process which are very important for you to know in this lesson. Now coming to the next topic. So any doubt you guys have from the topics that we have seen so far? From the 3 terminologies and from the 5 processes that I have discussed with you so far? If you are not having any doubt, just give me a thumbs up or type yes in the chat box. Any doubt? If there is no doubt, let me know in the chat box so that I can understand you guys have understood. Feel free to talk. Why you guys are so silent? Veni, is everything clear and okay for you? Yes. Okay. Everything is clear. Fine. So coming to the next point. Okay. So it is about the types of. Okay. You guys have raised your hand. I think by mistake you guys have raised your hand. So there is a thumbs up option there in the 3 dots next to you. If you click that, you will get the thumbs up, that thing. Okay. Okay, fine. Okay, I'll understand. Yeah, you have got it, Benny. Good. Good, good, good. If you're having any doubt, just raise your hand and ask me. Type it in the chat box. Okay. So I will tell that again. I will explain you and I will try to make you clear. Fine. Coming to the types of properties, there are 2 types of properties. One is intensive property and the other one is extensive property. Now, what is the definition and what is meant by intensive property? So the properties which do not depend on the quantity of matter are called as intensive property. Examples are temperature and pressure. The properties which do not depend on the quantity. Suppose, let me take this ice cube. So in the first case, I am having one ice cube and the temperature of this ice cube is 0 degrees Celsius. Now, here you see, I have taken two ice cubes. Now, I have changed the quantity. From 1 to 2, I have changed the quantity. But the temperature is still 0 degree only. Temperature remains same. So even after changing the quantity of the substance, if a property is going to remain same, then those properties are called as intensive property. Okay, so temperature is an intensive property. Pressure is also an intensive property. Got it? Coming to extensive, it is just the opposite of intensive. So what is extensive? Properties which depend on the quantity of matter. Properties which depend on quantity. Example, volume, mass. Volume and mass. I'll give you an example. So suppose, initially here I have taken a 5 kilogram of wooden log and one more 5 kg I have taken. So initially I have two separate 5 kg. Okay. But here I have 10 kg as a whole, two wooden log. So it is 5 plus 5, 10 kg. Now the property mass, here initially I have only 5 for one thing, but here I have 10 for one thing. So the property is going to change. The mass is going to change and the volume is going to change. Everything is going to change. So those mass volume, they are called as extensive property because on changing the size of the system, mass is changing. On changing the size of the system, volume is changing. So the properties whose value changes on changing the size of the system, they are called as extensive property. Okay. So these are the extensive and intensive. You just need to study the examples that is coming under each property. Like temperature and pressure, they are coming under intensive. Mass, volume, they are coming under extensive. No. So like this, you have to study the examples. They are very important. And you need to know the concept, the conceptual understanding of each term is very important. Okay. So thermodynamics is a physical chemistry lesson. So you can get questions. Most of the questions will be from numericals part based on the formulas that we are going to study. And also some theory part of question also will be asked. So for that, important that the conceptual understanding is very important. Okay. Shall we move on to the next topic? As types of properties, intensive and extensive, clear for all? Those who are watching, is this clear for all? Shall we move on to the next slide? Yes, good. Thank you. Thank you so much for your response. Yeah, good. Yeah, the next is types of function. There are two types of function. One is state function and the other one is path function. Okay. So in the last slide, two properties. One is extensive and the other one is intensive. Now here two function, state function, path function. What is a state function? The function which depends only on the initial state and final state, they are called as state function. You see here, internal energy, enthalpy, volume, pressure, temperature, all these properties, all these functions, they depend only on the initial and final state. They do not bother about the path in which it is going. It just need to have the initial value and final value. That's it. Okay, so these functions are state function. Coming to the path function, it depends on the path of the process. Path function depends on the path in which the reaction is occurring. Okay, so if I want to go from 1 to 2, I can use path A or I can use path B or I can use any of these paths or I can go like this also. Okay, any of the path I can take. I can take any of these two paths or I can create some third path also. Okay, so it depends all the values that is coming in between this 1 and 2 point. Examples are work and heat. Work is denoted by the letter W and heat is denoted by the letter Q. So except these two, All others are path function only. Okay, you just study this work and heat alone. If yes, if any other thing other than this work and heat, if they are giving you in the question, you just go for state function. Only work and heat are path functions. Other things are state function. Got it? Clear for all? Now let's go with the next topic, very important topic, which is the first law of thermodynamics. And before deriving the law, we will discuss one term, that is internal energy. So internal energy is represented by the letter U, and we have many properties that we need to know about this internal energy. So we will discuss those properties first, and then we will come to the formulas. Okay. So now the properties of internal energy. Properties of internal energy. So the first main important property is it is represented by the letter U. I have already discussed this, and it is a state function. State function means it depends only on the initial state and final state of the system. Okay. So the delta U, it will be equal to U2 minus U1. U2 means final state. U1 is initial state. Got it? And it depends only on the change in, dependent only on the change in temperature of the system. If you are increasing the temperature, internal energy also increases because temperature is directly proportional to internal energy. If you reduce the temperature, internal energy of the system will also get reduced. Okay. And it is an extensive property. What is extensive property? The value changes on changing the size of the system. Internal energy will change on changing the size of the system. So it is an example for extensive property. SI unit of internal energy is joule. It is an energy quantity, no? So it is represented by joules. And straight away, you cannot measure the internal energy. Only the change in internal energy is measured. Okay, the total internal energy cannot be measured. Only the change, only the difference between the two systems. That change is measured using some calorimeters. Okay, a bomb calorimeter we are having, coffee cup calorimeter we are having. So mainly we will get the change in internal energy value from bomb calorimeter. Okay, so there are some, those are the instruments which are being used to calculate the corresponding terms. Okay, so these are the 6 properties of internal energy. Now let's move on to the law of conservation of energy. Okay, energy can neither be created nor destroyed, right? So that is law of conservation of energy. And this internal energy can be changed by 3 things. One is by the heat exchange, the other one is by the work done, third is by entering the, when the matter enters or leaves the system, the internal energy can be changed. Okay, so there are 3 ways by which the internal energy can be changed. One is heat, second is work, third is matter entering and leaving the system. So let's start with heat. What is heat? What is heat transfer? So if I bring 2 objects together and if one of the object is very hot, automatically the heat will transfer from the hot object to the cold object. It will go from the warmer object to the cooler object, right? So this is called as heat. If the heat is entering into the system, which you can see here in this picture, if the heat is denoted by the letter Q, okay? So if the heat is entering into the system, then the value should be denoted by positive. It should be positive. And if the heat is released from the system, if it is going out of the system, then the Q value should be negative. Q value should be negative. Okay. So this is heat. Very important. While solving the numericals, you need to know all these things. When the Q value will be positive and when it will be negative, those things you need to study, you need to know. Okay. Now coming to the second thing, which is work. Here I am going to discuss about the mechanical work. It is the energy exchange between the system and surrounding against a constant external pressure leading to volume change of the system. So suppose if I'm having a container I'm having gas molecules inside that container and a piston is attached to that. Okay. So if I give some pressure, if I give pressure using the piston on the system, so this pressure is called as external pressure. The pressure which I am giving externally is called as external pressure. And the gas molecules which is there in the inside the container, they will also have some pressure, and that pressure is called as the pressure of the gas. Okay. Or I can tell this as internal pressure also. I can call this as internal pressure also. Okay. So because of this, there is an exchange of energy between the system and the surrounding against a constant external pressure, leading to the volume change of the system. Okay. So if the internal pressure or if the pressure of the gas is more than the external pressure, the gas will automatically expand. Okay. If the external pressure which I am giving, if this is greater than the pressure of the gas, then what happens? Compression occurs, right? So because of that, volume will be reduced. Volume will be reduced. Clear? So I'll show you one more thing also. From one more picture I will show you. From this you can understand. So this picture denotes that the work is done on the system. So this is the initial condition. This is the initial volume. That is the initial volume. Okay. This is the initial volume of the system. Now this is the external pressure. External pressure is more. External pressure is more. So because of that, compression occurs. Because of that, you see, compression occurs. Work is done on the system. This is the system and I am doing the work on the system. If the work is done on the system, then the W value will be positive. W value will be positive. Okay, this is compression. Gas is getting compressed. Initial volume V1 is greater than the final volume V2. Okay, it leads to the compression of the system. Now, coming to the expansion, so this is the initial thing. Now the pressure of the gas is more than the external pressure. So what happens? Gas is doing some work. Gas is doing some work. Means the work is done by the system. Gas is the system. So that is doing the work. So the work is done by the system. If the work is done by the system, then the value is negative. So if the gas is doing the work, automatically expansion occurs, right? Volume increases, final volume. This is V2 and this is V1. Final volume is more than the initial volume. Final volume is more than the initial volume. So the W value is coming out to be negative if the work is done by the system. Okay. So the sign conventions are very important for Q as well as for W. Clear? This is okay for all? Shall I move on to the next topic? Types of work. Shall I go with the types of work? So far what we have discussed is clear for all, right? Yes or no? Okay. Okay, my dear students. So let's go with, you're having doubt or it is clear? Okay. If you're having any doubt, put it in the chat box, okay? We'll go with the types of work. So, coming to this, there are two work, reversible work and irreversible work. Okay. And two pressure and the pressure volume graph for two works are here for you. The first graph denotes the pressure volume curve for reversible work. And the second thing denotes the pressure volume curve for irreversible work. And in case of reversible, when we increase the pressure from P1 to P2, okay, here I'm decreasing. The pressure is given in y-axis, right? So pressure is getting reduced from P1 to P2, it is getting reduced. So when it is getting reduced, the volume if you see, volume is increasing because we all know that pressure is inversely proportional to volume. If we increase the pressure, volume will decrease, and if we decrease the pressure, volume will increase. So they are inversely proportional. So when one increases, the other one decreases. So this is reversible. Coming to irreversible, so here the pressure is remaining constant. You see here, in both the cases, pressure remains constant. But volume is increasing from V1 to V2. Volume is increasing from V1 to, even though if I increase the pressure or if I decrease the pressure, volume is increasing. Volume is increasing. If the pressure remains constant also, the volume is increasing. So that type of work is called as irreversible work. That type of work is called as irreversible work. Now we will see the expression which is being used to calculate the work done for reversible, for irreversible, and for one more process which is called as free expansion. Okay. So first I have taken the isothermal expansion of an ideal gas. Here the temperature is constant. Isothermal means temperature is constant, right? And this denotes that delta U is equal to 0 because delta U is equal to NCV delta T. This formula I will discuss with you in the next slide. And isothermal means T is going to be constant and delta T will be equal to 0. So this whole term becomes 0. If it is 0, 0 into anything is 0. So delta U is also equal to 0. Okay. So same temperature means delta U will be equal to 0. And delta U is equal to W plus Q. So this is the first law of thermodynamics. This is the first law of thermodynamics. Change in the internal energy, it is equal to work plus W. Okay, and in this expression, if you substitute delta U is equal to 0, automatically W will be equal to minus Q, right? So now how to find out this work done? It can be done by calculated by three formula. For reversible case, W is equal to minus nRT into logarithmic function of d2 by d1. Or for irreversible case, W is equal to minus P external pressure into change in volume. And for free expansion, W is equal to 0. There is no work done because the free expansion is happening. So these three are the formulas you have to study and memorize to solve the questions related to work done. Okay, very important formulas. All these three formulas are very, very important formulas. Okay. Now, we have 5 more minutes. So we will discuss one more topic, enthalpy and internal energy. Enthalpy is denoted by the letter H. Enthalpy is denoted by the letter H. It is a state function. So it depends only on initial and final state. Okay. And also its SI unit is joule. Like internal energy, we cannot find out H directly. Only the delta H can be measured. Okay. And also we have one relation. H is equal to U plus PV. H is equal to internal energy plus pressure into volume. Okay, these are the properties of enthalpy. Now coming to the sign convention of delta H. Sign convention. If the process is exothermic in nature, then heat energy is released. If the process is exothermic, then it is clear that the heat energy is released. If the heat energy is getting released, then the delta H value will be negative. Delta H value is negative. And if the process is endothermic, endothermic means what? Heat energy is observed. Heat energy is observed. Then the delta H value will be positive. Okay. For exothermic reaction, it is negative, and for endothermic reaction, it is positive. You see the picture here? So this is the system. This is hotter. Okay, it is hotter. So what happens here? Energy, heat energy is going out. Heat is getting released from the system. Means the delta H value will be negative for this. And if the system is cooler than the surrounding, it absorbs the heat from the surrounding. If the heat energy is observed, then the process is called as endothermic. And if the process is endothermic, delta H value will be coming out to be positive. Okay, clear for all? I hope it is clear for you. If you're having any doubt, just put it in the chat box. Now I will move on to one relation, very important relation, which relates the internal energy and enthalpy. So delta H enthalpy is equal to delta U plus delta Ng RT. Okay. So this was the question asked in NEET 2023. Okay, NEET 2023 question it is. Which among the following is the correct relationship between delta H and delta U? This was the question. Such an easy question, right? It is not a numerical question, nothing to do with the max. So just you have to find out the formula, that's all. So very important formula, study. So delta Ng is the change in the number of moles of the gaseous product, change in the number of moles of the gaseous product minus number of moles of the gaseous reactant. That's all. So we will do this. While solving the numericals of this lesson of this topic, I will discuss this, okay? So that it will be, you will get clear. You will get clear idea of how to solve the questions and how to get delta Ng from the given reaction. And R is the gas constant here and T is the temperature. Clear for all? So I will move on to the next topic. I think it's already time, or shall I discuss? What do you guys say? Shall I complete this heat capacity topic, or we will see this in the next class? Okay, fine. I will discuss this in the next class. Okay. So we will look in detail about this, and after solving this, we will try to solve some numerical parts from the topics that we have discussed today, and from the heat capacity topic also in the next class. Okay. So what we have discussed today, all the thing related to first law of thermodynamics. First law of thermodynamics topics was discussed, and before that some basic terminologies I have discussed with you. The basic terms we have discussed, and the relationship between delta H and delta U we have discussed, and some relations about properties of internal energy we have discussed. So some sign conventions related to heat, work, and delta H we have discussed. Okay, so this is the summary for today's session. So in the next session, we will continue with heat capacity. Okay, if you're having any doubt, you can let me know in the chat box now. I'll give you a few seconds. So no doubt. Okay, then thank you so much for listening to today's session. Thank you. Bye-bye. Take care. Yeah. Take care, students. Bye.